Okay, we're going to start today learning about quadratic inequalities. So when you glue your page into your notes today, please label it as quadratic inequalities. Okay, what we want to start out with is assuming that this is just an equation so that we can find the boundary points. So I make it an equation. I can solve here by factoring or quadratic formula. I'm going to solve this one by factoring today, but if you would like to solve by quadratic formula, you can. Okay, by doing so, we get x equals -6 and x equals 2 as our boundary points. So that means we're going to make our number line. Remember that you have to at least have 0 and then the 2 boundary points showing. And we want to look at if the boundary points are included, and for that we are going to look at the original symbol here. Okay, so because of that, we're going to have closed circles. So that means -6 is a solution and 2 is a solution. If we were to plug those back into the original equation, they would make the equation true. So then the next thing we want is to be able to find out which way we are shading. So in order to do that, we are going to test different areas. So the area I'm going to test is the easiest one to test is because it's 0. So I'm going to look in here. I want to know, should I shade between those 2 orange points? And 0 is in there, so I'm going to test that in my original equation. So 0 squared plus 4 times 0 minus 12 is less than or equal to 0. Okay, I get 0 plus 4 minus 12. That ends up with -8 is less than or equal to 0. And then you have to ask yourself, is -8 less than or equal to 0? And it is. So that means I do want to shade where 0 is. So I shade in between those. Now, we could go on to test other areas. So if I wanted to test over here, I would need to pick a different number in that region. So maybe I could test -8. And then I would need to pick a number in this region over here. So a number over there, I could test 3. If I did that, I would find out that they are false. For inequalities, we are always going to be shaded either between the 2 points, so it would look like this, where we are in between, or we would find that we have to shade outside the arrows. They are always going to either come together or go outside. So then the next thing I need to do is to actually write my final answer. The graph is part of my answer, but I also need to have my algebraic answer written down. So let's just give me some room here. And my algebraic answer, if you look at the graph, the way we would explain that would be numbers between -6 and 2. The way that I write that is to have x in the middle. Okay, and notice that my original had the equal to underneath, so I'm going to add mine in as well. I'm going from -6 to 2. Solutions are anywhere between -6 and 2 and including -6 and 2. And make sure when you do problems like this that you are giving a graphical answer and an algebraic answer. You need to have both of them together to get full credit. Okay, here's a new problem now, and for this one, notice that it is not set up as nicely as our last one, so we do have to do a little bit of work here first. We are going to come over here on the side and do a generic rectangle for this. When we do that, we would get x squared minus 4x plus 4, and then we still have the -1. Over here we have x minus 1. And then in order to be able to use the quadratic formula or factoring, I need this equal to 0. So I'm going to move these things over and do some combining like terms, and I end up with 0 less than or equal to x squared minus 5x. And then my 4 and my -1 on the left makes 3. I'm going to add one more, and we get 4. And now I have my equation, so I can go ahead and solve that. I can use, again here, factoring or quadratic formula. I'm going to use factoring. You could use quadratic formula if you want, but I get x equals 4 and x equals 1 as my boundary points. So I can now create my number line. Here's 0, 1, and 4. And I look at my very original problem. And that means I'm going to have closed circles. Okay, and now I need to test a point. So I need to pick a point, and I get to choose mine. I, of course, want to test something easy, so I'm going to choose 0. And I do want to plug it back into the original equation, even though that's not the nicest looking equation we've got. Just in case you made a mistake somewhere else, using the original will help. So you can see I plugged 0 in there. We're going to get negative 1. On that right-hand side, 0 minus 2 is negative 2. Squared 4 minus 1, we get 3. So then we have to say, okay, is negative 1 less than or equal to 3? And it is true. So I want 0 to be shaded, so I'm going to shade this way. And like we talked about in the last example, yes, we should or could test points in the other region. So I could test a point in here like 3. I would find out that it's false. And I would test a point in the other region, which is over here. I could test the point 5, and I would find out that that's true because they either have to be going separately away or coming together. Okay, and then I need my algebraic solution. So before we had one that was in between. This one we have 2 different sections, so we write them separately. We say x is less than 1, or, and you do have to write the word or, x is greater than 4. Okay, and I also need to have that equal to underneath because my original problem had that.